Good evening and welcome to NPTEL classes. Today I am here to solve Chemistry class 11th NCERT problem 2.39 from unit 2nd, that is structure of atom. Let me make you understand this problem. It is given that during Millikan's oil drop experiment, magnitude of charge on oil drops was observed equal to minus 1.282 into 10 to the power minus 18 coulombs. And for determination of magnitude of charge on oil drops, X-rays were used in order to cause ionization of gas so that electrons are ejected from gaseous atoms. Now we need to calculate the number of electrons present on oil drop. After reading this problem, I got that problem is based on concept of Millikan's oil drop experiment. Very briefly, I will share you important points of this experiment. Aim of experiment was to determine magnitude of charge on one electron. Aim of experiment was to determine magnitude of charge carried by one electron. For that, idea Millikan used is, I will not go into the details of experiment, I will just tell you idea. Millikan used the idea that if electrons are somehow made to come in contact with oil drop, they will get stuck with oil drop, they will reside on oil drop, and thereafter he can determine magnitude of charge carried by oil drop, from which he can determine magnitude of charge carried by one electron. This was the idea. Idea was to allow electrons to come in contact with oil drop so that different number of electrons will reside on oil drop, and thereafter he determined magnitude of charge on oil drop, from which he got magnitude of charge on electron equal to 1.6 into 10 raised to power minus 19 coulombs. Of course, it is negative charge because electron carries negative charge. And during his experiment, he found that magnitude of charge on an oil drop is equal to integral multiple, that is small n, integral multiple of some fixed value of charge, and fixed value he found equal to 1.6 into 10 to the power minus 19 coulombs. Magnitude of charge on oil drop was found to be equal to integral multiple of fixed value of charge, and fixed value of charge was in itself equal to 1.6 into 10 raised to power minus 19 coulombs. Now, how he could determine magnitude of charge carried by one electron? Let us focus our attention on experiment. What is the possibility? How many electrons can reside on an oil drop? Minimum number of electrons that can reside on oil drop is 1, followed by 2, followed by 3. It cannot be 0 electron. It cannot be fractional, because half electron does not mean anything. Fractional 1.5 electron does not mean anything. So minimum number of electrons that can reside on oil drop is 1, and maximum number can be 2, 3, 4, any integral value. So this n, I can write this equation like this. I will represent magnitude of charge carried by an electron. Magnitude of charge carried by an oil drop. I will represent it by small q. Magnitude of charge on oil drop I will represent by small q. Small q will be equal to integral multiple of 1.6 into 10 to the power minus 19 coulombs. And n here is integral value. Cannot be 0, cannot be fractional. N is integral value. It can take minimum value 1, followed by 2, followed by 3, etc. depending on number of electrons that reside on oil drop, that are carried by oil drop. And more importantly, n is number of electrons. In this problem, we have to calculate number of electrons. More importantly, small n here is number of electrons. Number of electrons carried by oil drop. I may further write this equation. Further, I may write this equation like this. Or let me come to this point. Minimum, how I will tell you how he determined it. Magnitude of charge on one electron. What is minimum number of electrons that can reside on oil drop? 1. So let me substitute let me put here value of n equal to 1. What will be the magnitude of charge carried by oil drop then? Magnitude of charge carried by oil drop will be 1 multiplied by 1.6 into 10 to the power minus 19 coulombs, and Q will be equal to 1.6 into 10 to the power minus 19 coulombs. What is this Q? Q is magnitude of charge. Q is magnitude of charge carried by oil drop. And how many electrons are this time on the oil drop? 1 electron. So this magnitude of charge on oil drop is actually the magnitude of charge carried by 1 electron. And from here, Millikan got that magnitude of charge on 1 electron is 1.6 into 10 to the power minus 19 coulombs. Magnitude, this is I may write here, this value is magnitude of charge carried by an oil drop which carries 1 electron. Therefore, this is magnitude of charge carried by one electron, and I will represent it by small e. This magnitude equal to 1.6 into 10 raised to power minus 19, I will represent by e. Then I may write this equation. I may write this equation like this: Q is equal to N and multiplied by small e. What is Q? Q here is magnitude of charge carried by oil drop. N is number of electrons carried by oil drop. Small e is magnitude of charge carried by one electron, and that I calculated equal to 1.6 into 10 raised to power minus 19 coulombs. Small e is equal to, if I need to substitute value of small e, I have to substitute 1.6 into 10 raised to power minus 19 coulombs. Now, what will be the magnitude of charge carried by oil drop if it carries 2 electrons? That time magnitude of charge carried by oil drop will actually be the magnitude of charge carried by 2 electrons, which is 2 times 1.6 into 10 raised to power minus 19 coulombs. What will be the magnitude of charge carried by oil drop when it carries 3 electrons with it? It will be magnitude of charge carried by 3 electrons. 3 into 1.6. What will be magnitude of charge carried by 3 electrons? Magnitude of charge carried by 1 electron multiplied by 3. So at the start I said that magnitude of charge carried by oil drop is integral multiple of fixed value. And what is this fixed value? Magnitude of charge on 1 electron equal to 1.6 into 10 raised to power minus 19 coulombs. Now I will use this equation. For basically all 3 equations are same. If I label it equation 1, if I label this as equation 2, both equations are same. Here I represent 1.6 into 10 raised to power minus 19 coulombs by small e. Rest all are same. Now coming back to problem. Magnitude of charge on oil drop is given. Q is given. Magnitude of charge on 1 electron now we know equal to 1.6 into 10 raised to power minus 19 coulombs. We can easily determine number of electrons that reside on oil drop, and number of electrons that reside on oil drop is equal to Q. Number of electrons that reside on oil drop is equal to Q divided by E. Now Q is magnitude of charge carried by oil drop. Here it is equal to, in the problem it is said, it is given that magnitude of charge carried by electron is magnitude only. I am not interested in sign, magnitude only. And magnitude of charge carried by oil drop is 1.2 A2 into 10 to the power minus 18 coulombs. And what is magnitude of charge carried by 1 electron? 1.6 into 10 to the power minus 19 coulombs. N will be equal to coulomb, and coulomb will get cancelled. I have to divide 1.282 into 10 raised to power minus 18 by 1.6 into 10 raised to power minus 19. I will get number of electrons equal to 8. On solving, I will get number of electrons is equal to 8. Therefore, number of electrons carried by oil drop in this experiment, in this problem, are equal to 8. Therefore, I can say 1.282 into 10 raised to power minus 18 coulombs is actually the charge carried by 8 electron, and it will be equal to, if I will relate it with charge on 1 electron, it will be equal to 8 times magnitude of charge carried by 1 electron. This value 1.282 into 10 raised to power minus 18, it is 8 times the magnitude of charge carried by 1 electron. Let me Sum up the problem. Problem was based on concept of Millikan's oil drop experiment. It was given that static electric charge on oil drop was measured equal to minus 1.282 into 10 raised power minus 18 coulombs. Now we need to calculate number of electrons that are present on oil drop. I said problem is based on Millikan oil drop experiment. In this oil drop experiment, aim of Millikan was to determine magnitude of charge carried by one electron, and for that idea he used is that he made electrons to get stuck with oil drop. He made electrons to reside on oil drop. He made oil drops to carry electrons, and then he calculated magnitude of charge on oil drop. What he observed? He observed that magnitude of charge on oil drop is integral multiple of fixed value 1.6 into 10 raised power minus 19 coulombs. He interpreted this equation like this, that minimum number of electrons that can reside on oil drop is 1 and maximum can be 2, 3, not 0, not fractional. Therefore n is integral value, and n for us represents number of electrons carried by oil drop. Then how he was able to determine magnitude of charge on one electron? He substituted here value of n equal to 1. He got magnitude of charge carried by oil drop equal to 1.6 into 10 raised power minus 19 coulombs, which is basically the magnitude of charge carried by one electron represented by small e. So I wrote this equation: Q is equal to Ne. Q is magnitude of charge carried by oil drop. E is magnitude of charge carried by one electron. N is number of electrons that reside on oil drop. Now coming to problem, magnitude of charge on oil drop was given. Magnitude of charge on electron, now we know 1.6 into 10 raised power minus 19 coulombs. On dividing magnitude of charge carried by oil drop by magnitude of charge on one electron, I got number of electrons that reside on oil drop is 8. And one more information data gives me is that in this experiment, magnitude of charge on oil drop was observed to be 8 times greater than magnitude of charge carried by one electron. This value is 8 times greater than 1.6 into 10 raised power minus 19 coulombs. Class 11th students, be blessed. This is what I had for you today. Take good care of yourself. See you day after tomorrow, as tomorrow is turn of class 12 students. Allah Hafiz.